Alright, time for another DraftPhysics.com video presentation. So this will be a response. I'll play this Leksa video, but there's really not too much point in it because he's not following along at all. I mean, it's just not even close. So I have requested that people play the beginnings of the videos, the places where I'm drawing on the board, explaining a concept. That's the part to respond to. And those pleads go ignored, and frankly, just I can't think of this as anything other than just trolling. It's so obnoxiously disconnected from what I actually say in my videos. And so this quote mining bullshit is just that bullshit. Not interested. And it's just rude, frankly. But anyway, I'm going to draw on the board. This is the part I want you to respond to. So what's already been established is you've stated overtly that you don't believe in the principle of conservation of momentum in a system where we're not going to add anything else, a closed system. You must conserve momentum. That's what the physicists say. Now, if you want to argue that you don't have to do that, then argue with them. Okay, argue with Professor Lou and argue with somebody else, because frankly, I agree with conventional physics that you do have to conserve momentum. So you're opposing the conventional theory. You're not opposing me. All right, so the simple idea is my claim is that springs, okay, levers, and let's just use hydraulic systems, okay, and we'll represent that with 2 cylinders versus 1 cylinder kind of idea. You know, that if I double these cylinders in a pressurized vessel, blah, 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 and the levers are kind of a simple idea in a spring. I'm saying all of these mechanisms allow you to do something the Newton's cradle can't do, right? The Newton's cradle can't take the energy from a big object and give it to a small object, or vice versa. It fails in the sense that not all the energy is transferred, and it creates a broken oscillator where if you use the same mass, you are able to move the energy freely between the 2 objects. So that's a weakness of the Newton's cradle as an experimental device. But springs and levers and all these other mechanisms are capable of doing the conversion. They're taking all of the energy, all of the momentum from one object, and they give all of it, okay, to another object. So unlike a bowling ball hitting a pin, where only part of the energy goes to each pin, okay, the ball doesn't give all its energy to the first pin or the second pin. No, it gives its energy in pieces because the ball is much more massive. And the pins, frankly, can't leave very fast, okay, because there's no mechanism to create this extra speed. A pusher can only push the speed they're going. They can't push faster than they're going unless more energy is coming in. So you've already conceded you don't think any of these things conserve momentum. I'm saying that's nonsense, and until you show experiments, there's no point in us continuing the conversation, okay? But the whole argument is that your science, that's had 300 years to prove some of its theories, hasn't proved any of them. They haven't done any of the experiments. They haven't shown that their theory has any validity at all. And what I'm claiming is 1/2 mv squared, which was, frankly, invented well after conservation laws were established. And the fact is it's completely obnoxious to the conservation laws. You can't do it. It's impossible to conserve kinetic energy and momentum. It can't be done when you're transferring between light objects and heavy objects, or heavy objects and light objects. If you're going from light to heavy, you're going to lose a ton of energy. And if you go from heavy to light, you're going to be making free energy. And that's just the simple facts, okay? You can't evade the facts, and the 5-ton train and the 10-ton train thing, okay, pretty much decisively shows this truth, okay? In the one sense, if you can combine the 5-ton going 10 and you create the 10-ton going 5, perfectly conserving the momentum, making perfect sense. You're basically saying this is bread and the velocity is the butter. And you're basically saying, well, if I have more bread, I have to spread the butter thinner. And it adds up perfectly. Your theory, your 1/2 mv squared, says somehow I conserved all the momentum, and yet somehow I lost half the energy. So somehow I made heat, and I made other things move away from the system. I moved them out of the system, okay? And yet somehow they're still here because it's momentum. I mean, you can't really move something without using momentum. It's a simple argument. And the worst case is the idea of going from the big thing, doing the conversion with, say, a lever. You put your big thing close to the fulcrum. You put your little thing far out here on the fulcrum, and that will perfectly balance. You will perfectly conserve the momentum. You'll have big V, little m over here. You'll have big M, little v over here. Big V, little m, big M, little v. They will convert the energy. If you put them at just the right places, you'll actually be able to perfectly match in terms of, you could even think of it as a wavelength. You'll be able to put the differences in their acceleration into perfect units, so that this one's deceleration, the big object, and the acceleration of the little object will be in perfect matched units. And therefore, at those perfect locations, you will be able to strictly, plainly convert, okay, from this big mass going slow into small masses going fast. And the fact is, this will create free energy by your kinetic energy theory, meaning this can't possibly be the truth. So if conservation laws are true, kinetic energy theory doesn't work, because it does create free energy, and we know free energy isn't possible, so it's a dead theory. It can't be the truth. And if you're going to say there are no conservation of momentum laws, then you should tell Professor Lewin to quit saying things like nature can deal with kinetic energy one way or the other, but nature can't finagle momentum. You ought to tell physics that they ought to change their principles, and that there is no conservation of momentum, that somehow you can destroy it and create it, and it doesn't mean anything. So that's where the argument is. All right. Now he's going to misparaphrase me all over the place, put words in my mouth I never spoke. And it's just disgusting, frankly. I shouldn't have to deal with arguments of this low, crappy character. So he provided no evidence in his video, his previous video, the one I responded to. I pointed out how it doesn't even make sense. The drawings aren't saying anything at all. It's just useless mush. All right, what he has to do is provide evidence. We're all claiming things, and the whole point is physics hasn't done these simple experiments. I mean, I've said it literally 100 times. Where have you proven or shown that it takes 4 times the fuel to go twice as fast? Don't you have a single frickin' experiment you can show me where that happens? It's been happening by your theory, by your statements, by your overt statements for 350 years. You think you could show one example. Respond to that point. In 350 years, you can't produce one piece of experimental evidence showing it takes 4 times the energy to accelerate something to twice the speed. Not one. Damn it.
Okay, making a new response video.
Yeah, it's the same crap, frankly. Crap.
Go to DraftScience. Trying a new format here, so I have clipped some parts of your video.
Right, exactly what I told you not to do, is quote mine me. I deliberately make, the last 10 videos, I have deliberately done all the drawing in the beginning, made my points. These are the things I want to discuss, and you want to discuss something completely different.
Here, and we'll play them one by one and try to respond to them. So let's start with the first one. note that.
So what context is there here? Absolutely none. What does he say this drawing is of? Okay, I think it's supposed to be a half mass going twice the speed, a full mass going half the speed, hitting a spring, and what do we say happens? I'm obviously saying they compress the spring exactly the same amount. He's saying they don't, and he has nothing to show me as an experiment.
When we are talking about spring compression, we can talk about either the length of the compression, meaning how many inches or centimeters we are making the spring shorter.
So again, I point out how it's completely meaningless. We already established its velocity. We're just saying what compresses the spring? Momentum or kinetic energy? What compresses it? I'm saying clearly momentum compresses the spring, and momentum is what it gives back. And that it conserves the force. Whatever force you put into the spring, it generally conserves it and throws the thing back exactly at the speed you threw it in with a perfect spring. But at least you get some percentage of that, 80%, 90%. It's some decent percentage of the energy you get right back from that spring compression. So who cares exactly how? I've pointed this out hundreds of times. It doesn't matter how fast you compress the spring. It doesn't matter how fast I get to a certain weight. I'm going to get a certain pressure back. If I put that much pressure into the thing, I'm going to get that much back. That's how much I'm going to get back. And it doesn't matter whether I press it really slow or I go in really fast. It matters on how far this little needle goes. That's all that matters. Damn it.
Or we can talk about the duration of the compression.
I don't see any point in talking about the duration. Doesn't mean anything.
But I think that you have often said that it's duration that is important.
No, I've often talked about gravity. You don't know these are different subjects, that a baseball moving and hitting you in the face isn't the same as gravity. I've pointed out the elevator floor isn't the same as gravity, okay? These things are material objects hitting you. It's very different than a force hitting you. Gravity or photons or magnetism, these are all forces, okay, that affect things by the inverse square law that are like paint sprayers. Photons like a paint sprayer. A baseball hitting you in the face is not like a paint sprayer. You can't understand that distinction. I mean, I made these videos pretty clear. I mean, it's clear when I'm talking about how gravity works and then how I'm talking about how a train works. A train and gravity are not the same thing.
Not the distance. So, for example, your definition of work is force times the duration. Am I right?
Force times time. That's right. And that's work in the context of gravity. So again, I'm not going to keep arguing this, but yes, it's the same. The same is true for springs and the rest of these things. It's about the velocity, how much you put in. But I'm going to plainly state that has to do with how the spring expands, not about how you compress the spring. You can waste a lot of energy lifting a barbell. Again, the same arguments I've done over and over and over again. If I take 10 minutes to lift 100 pounds, I'm obviously doing more work. You think it's the same amount of work no matter how slowly I lift it. Okay, that's what your physics says. Same work. I'm obviously saying, no, it's a lot more work because the thing is in the gravity the whole time. So it's a gravity argument essentially, right? And friction is gravity argument. So gravity gets into these other subjects, but there's no law that it's, work has something to do with time. No, work just has to do with momentum and moving it from one object to another. I've already pointed out there's no such thing as work. Work is like heat. It's a part of energy. It's not energy. Okay, work is a word we use for the stuff we want to glean out of something. We want to pull the certain part of it, and we want to ignore what we call the stuff that's waste. But it's all the same thing. It's energy. Work is just a portion of it by your own contrivance. What I've said is I wouldn't have the word. Work is the same as heat, is the same as weight, is the same as momentum, is the same as energy. It's all the same thing. That's what I've said.
Right. So here we have two springs applying equal amounts of force, but the duration...
I mean, the arrows are pointing in, so I really don't understand. Again, what is this drawing? Shit.
is different. So how does that play out?
So it says they're different. So again, you're saying so. You're saying that somehow it's a different work, it's different anything. I'm saying momentum works perfectly explains this circumstance. So where's your evidence? I said it in the video. Where's your evidence? Where's your experimental evidence showing what you claim to be true? Shit. Because depending on what mass I put in front of it, of course, the velocities are going to be different. The duration is going to be dictated by the velocity.
And how about the paint sprayer analogy?
It's not a paint spraying analogy. You're not using gravity in this case. I don't know what you used. You're just establishing that this is going twice the speed of this, and that's all we have. We don't have anything else. And I'm telling you that, yes, what's going to happen is it has a certain momentum. It will compress the spring a certain distance, and these two things will weigh the same. They have the same weight. I stated in a previous, just in the last video anyway, that if you want to weigh something on a horizontal scale, that all you have to do is make it go 1 mile an hour. I can take any object, move it 1 mile an hour, and it will create an impulse. That is, it won't be a lasting pressure, but it will create an impulse pressure that will be its atomic weight. I mean, it's, it'll reveal its material weight. Its mass will equal its weight.
Does it apply here?
Of course not. So what? That'll be compensated for by the math. The mass is the simple argument. I mean, you really can't get this. So I have made all these analogies. All you have is mass and velocity, and they're equal players. The mass is the bread, the velocity can be the butter, however you want to do it. And all you do, you have less bread, then you have thicker butter. You have more bread, you have thinner butter. Things go slow, the light things go fast, okay? And it really won't have anything to do with how much pressure they can exert, in the sense that their pressure will be just a simple calculation of their mass times their velocity. Those are the only things that are relevant, and you don't need to put a 1/2 and a square on them. So again, just play my video and not respond to any of it. Okay. Superfluous, non-real things don't enhance understanding at all. The real things are mass and velocity. The completely artificial, useless, mushy, cruddy stuff is just this 1/2, whatever that is, and a square, for whatever reason.
You've been studying these things for many years now, and many people have tried to explain to you where those come.
Oh, whatever. I mean, you haven't explained anything at all. All you've done is crappy derivations that have nothing to do with the truth, okay? So per second, it's nonsense talk. I plainly state it in videos. Why don't you explain how per second makes any fucking sense? I've made the simple argument. Nobody says I'm going to the store at 60 miles per hour. No one says that. No one thinks that. That's not how it works. You're going 60 miles per 1 hour. If you squared 1, it wouldn't do you any good. It's obvious. I mean, in yesterday's video, I detailed that again. I made that argument clear in the beginning of the video. So this is, again, just jargon, just mush. Sorry, you're wasting my time, okay, with your nonsensical, irrational mathematics. It's just plainly irrational. It doesn't have anything to do with anything real. You've just faked it. It's just bullshit.
They have given different explanations from different points of view.
Yeah, exactly. Just mush. Mushy, contrived nonsense. Scalar versus vector doesn't make any goddamn sense. You just invented the words. You just put them on the concepts to make to make you have some capacity to explain a tiny percentage of the possible experiments that could have been done. So you only have these little niche experiments that you'll do. You won't touch reality at all. You won't ever show the lever, because guess what? You can't, because it shows your theory is nonsense.
So, of course, you don't have to accept those explanations as useful descriptions of reality, but
Yeah, I don't. I've made that clear. So until you can come up with some kind of experiment that actually shows this crap to be real, forget it. Yes, and I've shown the opposite. I've shown the Toady video that clearly shows the twice mass hitting the one mass. Okay, in Newton's cradle, they crash into each other twice the speed, had twice the mass. They crash into each other. The crash doesn't go anywhere at all. The thing with twice as much energy doesn't move the collision at all. The fact is, there's no evidence that your fake energy does anything real anywhere in the universe. It's fake, fable energy.
Still, it's a bit strange that you're saying, for whatever reason, as if you didn't have a clue where they come from.
I've already responded to them in multiple videos. I've pointed out how per second is illogical baby talk, frankly. It's just goddamn baby talk. You have absolutely no reason to say per second in the case of an acceleration. There's absolutely no reason to say it's per second and find some excuse to square that when those two numbers aren't even the same. The time that you're squaring, okay, these aren't even the same seconds. One of them is the 9.8 per 1 second. The other one is how many 9.8s happened. How many seconds. 1 second times how many seconds is how you're supposed to do the math. And those 2 second numbers aren't going to be the same number.
I think that at this point you should have some kind of idea about the reasoning in conventional physics. If you're trying to...
The reasoning is all circular, and it's all in an effort to defend some wacky, silly theory that should have never gotten off the ground in the first place, because every single argument made in its defense was nonsense. Again, dropping round things into clay.
Argue against conventional physics.
Which has nothing to do with reality. Clearly, my argument is you have no fucking evidence, okay? You haven't bothered to do what science requires you to do, which actually back up your claims with some kind of physical evidence, and that you haven't done. You don't repeat experiments, you don't even do experiments. All right, 300 years, billions of dollars, and you've never proven any of this crap. Again. And is only defended because you people say something as silly as 9.8 meters per 1 second squared. Per second. There's no per second.
And you say silly things like meters.
Okay, so fuck you. Okay, you're not going to respond to the point. So what is it? Where does that come from? What's the point of it? Why are you saying per second? There's no per second as a reality anywhere. Per second. Should I say it 6 times? Can I say it 43 times? How many pointless times can I say something pointless?
The second, when you're talking about velocity.
And there's nothing wrong with saying meters per 1 second. That's what per second means. 1 second.
How does that make any sense physically? You have a distance, then you're going to divide it, but not into...
By a unit, 1 second. That's what it's supposed to be there, okay? And so it's just a shorthand trick that they don't put the 1 in because it's supposed to be obvious. Just as the meters are 1 meter. You're multiplying 9.8 times 1 meter.
Segments of smaller distances, but you're going to divide the distance by some amount of time. Isn't that just crazy talk? I mean, it doesn't make any sense.
I'm sorry, what you just said is just garbage and goop. What the fuck are you talking about? It doesn't make any sense. It's what the ratio is. There's no fucking 9.8 without the 1 second. If it's not if it's 2 seconds or 5 seconds, then it's a different number. It's not 9.8 anymore. Dumbass.
Until we understand what is meant by the notation in this context.
Nothing is meant by it. It's a contrivance, okay? It's just merely invented for the purpose of creating living force. That's all it's for. It doesn't do anything else. There's absolutely no reason. Again, I could state, where exactly do you have any evidence that Newton got a wrong answer? Where do you have any evidence that momentum didn't work? That Descartes got a bunch of wrong answers? That Galileo got a bunch of wrong answers? not believing in your special living force energy. So where's the evidence that this need to be fixed? Oh, that's right. There is no evidence it need to be fixed.
So we understand that meters per second or distance divided by time is the distance traveled within that time. So it's a description.
La 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 la. So again, I drew on the board the planet with the guy flying by. He's going to go a certain distance, and frankly, the faster he travels that distance, he's going to get completely different effects from the gravity. That's a fact, okay? And you just keep ignoring it and playing this crap instead. Your distance idea of force application, it doesn't work. Okay, and the only two cases it does work is that, yeah, you start with a zero velocity, then you can guarantee distance will be the same because the free fall weight rate is the same with all things. And the friction argument, the rolling friction argument. These are the arguments I wish you to play. I've played the rolling friction argument over and over again. You think friction is linear. Completely idiotic thing for you to think. I pointed out how the thing doesn't go half the speed till it's 3/4 down the track, proving it's not linear.
Of velocity. And when we understand this, it makes sense, and we can use it in calculations because it works mathematically.
Fuck, it does. You're getting completely wrong answers. You have a completely fake notion of reality, and the whole invention of all your neutrinos and all this other crapola that you've invented that is all nonsense is all a byproduct of you getting wrong answers, thinking electrons have much more energy than they actually have. Because you aren't doing the math correctly. You're not landing on the moon, you're crashing on it.
For example, if we travel 10 meters, we spend 2 seconds doing that. The notation tells us that the average velocity...
The average velocity is completely meaningless in any of these points because the point is how much momentum does it have. It's not going to get its momentum from any average velocity. Meaningless garbage.
Is the distance 10 meters divided by the time 2 seconds, we get 5 meters per second. Makes sense, and it works.
That doesn't work. What is that? That doesn't work. Your average velocity is not telling you how much energy the thing has because of its velocity. So just mush, garbage. 2 seconds is 2 units of gravity. You're going 19.6 meters per second. If you're moving in gravity, again, you're drawing this horizontally. I don't really understand what the fuck you're talking about. There really isn't. This isn't enlightening in any way. This is just trolling, frankly. Just, well, let's waste people's time.
And it's the same thing with acceleration. So if you accept meters per second, you just need to replace the distance by velocity. Because that's what is changing over time when we are talking about that.
Says you. Okay, you want to change something. You don't want to go with the regular formula that works perfectly fine. Again, I'll get perfectly fine answers if I understand that I get 9.8 unit of energy for every second. No, that's all that works. It works perfect. It predicts the velocity and it predicts the momentum. Why do I need to do any of this crap?
Acceleration. And this, of course, equals 2 meters per second squared.
This, of course, does. I don't even know what you just did, so I don't even know why. What is this? Meters per second divided by seconds. Again, why would I do that? No good reason.
And let's take a look at an example. So let's say we change our velocity by 10 meters per second.
Nobody's interested, okay? I'm sorry. This whole debate is not going to be hinged on you writing this gibberish, okay? The point is show me a fucking experiment, fuckhead. Link me to your evidence, okay? Show me a piece of fucking evidence demonstrating any of this crap to be reality. This fucking gremlin math doesn't mean a damn thing.
And so we, for example, start at 0 velocity. Then we accelerate for some time until we reach the velocity of 10 meters per second. And let's say it takes 2 seconds to do.
There's rules about how long it takes, frankly, okay? And in gravity, the rule is 9.8 meters per 1 second. That's the rule. So you can't just make up some, it takes this many seconds. Again, as I pointed out, I can lift a barbell at some preposterously slow speed, and I'm not going to get, the amount of time is going to matter. And every second, I'm going to still be fighting the gravity. I'm still fighting the gravity. I'm still fighting the gravity. I'm still fighting the gravity. So even though it's this little tiny distance, the fact is I expended a huge amount of energy fighting the gravity. I've pointed this out. Rocket engines get hugely more efficient the further you're shooting for. The farther you go, the faster you go through the gravity, the less gravity affects you, and the less fuel you'll have to use. Those are facts.
That. Now the notation tells us that we get the average acceleration by dividing the velocity, 10 meters per second, by the duration, by 2 seconds.
Why would I want the average velocity? Again, just meaningless. More meaningless crap that doesn't say anything about the reality.
So we get 5 meters per second, which is 5 meters per second.
But wait, per second again. Why would I say that? Why would I do that? Of course it's per second, but there's still a certain number of seconds. It's 2 fucking seconds in this case. It's not per second squared. There's 2 seconds. 1 times 2 is 2, and that's all you have. The end.
Squared. So if we have this acceleration, we accelerate for 2 seconds. It's quite easy to calculate what is the change in our velocity. Well, let's actually do that. So we have an acceleration of 5 meters per second squared. We accelerate for 2 seconds. So our change in velocity is now 10 meters per second. It's really this simple. I mean, there's no tricks in...
Fuck you. Alright, this argument for 2 solid years has been about evidence, fucker. You don't have any evidence of this shit you're typing. So what's the fucking point, jackass? The accusation is your theory has had 350 years to demonstrate any of this crap, okay, to prove it takes 4 times the fuel to go twice as fast. Will you show me one fucking experiment that demonstrates that to be true? Fucking pusshead.
Involved here. And I would say that this is by far the simplest thing that people have been trying to explain to you.
Go fuck yourself.
I just keep wondering that if you don't understand this, then is there any point in talking about
No, there's no point, because you
stuff?
have no fucking evidence.
The very difficult stuff, if this is way too complicated for you.
Yeah, fuck you. Fuck you.
I don't know. But let's go to the next clip.
Directions. And just for the sake of the argument, let's make 2 assumptions. The first is that both springs create equal amounts of total momentum, and the second one is that each spring creates equal momentums to both directions.
Okay, wrong. So that doesn't happen. So he's put different size masses on here, right? And I'm clearly stating there's absolutely no reason. The spring has the same compression. It has to create the same momentum out. So the total momentum has to be the same in both these experiments. The spring is going to expand. It's going to push a heavy thing. It's going to push a light thing. It has to create the same total momentum.
So what do you think about Newton's third law? I think it's...
You're the one violating it. Fucktard. Jesus Christ. I mean, the equal reaction has to be in momentum. Newton believed in momentum, not kinetic energy, retard. Do I have to explain that to you? He doesn't believe in conservation of kinetic energy. He believes in conservation of momentum. Fuck. The third law was written understanding momentum as energy.
I think it quite clearly says that the momentum would be the same to each direction, to both directions. So
no, it clearly doesn't. Right, the momentum will be the same in both directions, not the velocity, not anything else. But again, we obviously know that if I make that one object heavy enough, no momentum's going into it. So the spring has to give all the energy to the other side. There's no choice. If the spring is on a brick wall, I get the thing back at the speed I threw it in at. Clearly. So, yeah, so I guess in that case you want me to tell you that the third law is misunderstood. I've already pointed that out, how I would rewrite the third law, okay, because there is no opposite reaction. There's just the bowling ball gives away its energy to the pins. There's no opposite force that took it away. It just gave it away.
Do you think Newton's third law was a mistake, or do you have a different interpretation of it, or what?
I mean, clearly it doesn't happen. So, as soon as this side yields, right, the light object on this spring means this light object is yielding. This 10 can't possibly go the same speed as it's going to go here because it's getting all the energy here because this is not going to yield at all.
Well, it's going to yield a little bit. I mean, that's just momentum.
I'm sorry, it's not going to yield a little bit. So you say it yields a little bit. The Empire State Building yields. I throw a tennis ball at it, it yields. It doesn't yield. That's why I get the ball back. It's because it doesn't yield. And as soon as I make it yield, that is, as soon as I put it on really slick grease or something, then I get less tennis ball back.
It has a higher mass, so it gains less velocity, so it's moving very slowly.
Says you.
And the difference why the 10 mass balls won't gain the same velocity is because the total momentum is different between the two springs.
So he says it's the same spring compression. Now he says the total momentum is different between the two springs. Now, that's not conservation of momentum, okay? So if I'm going to break something, like I said, I don't know if Newton's law had really anything to do with, this particular scenario we're using a storage device and then re-releasing the energy. But yeah, it's a fact of springs, I guess you could argue, is that they're differential to whatever is easier to move. And there's no, I would argue, law for that. It's not some linear thing. It just has to do with the fact that you're going from, as I drew in many videos, you're going from the Newton's cradle perfect exchange, and now you're making something heavier. Well, you can make it twice as heavy and you still get a lot of momentum. But if you make it 4 times as heavy, you don't get any momentum. Yeah, the more a surface yields, the less the thing can bounce. The more I throw a tennis ball at a wall, if the wall starts moving, the tennis ball is not coming back at the same speed. And if it moves really, really easily...
Okay, I don't think there was anything interesting at this clip anymore. But yeah...
Oh, yeah, so he didn't respond to the point. It's all about the yield. If it yields, if it accepts the momentum, then yes, I'm going to conserve the momentum. It's going to eat a piece of that momentum, and I'm not going to get back as much. But I get 100% back if it doesn't yield. Just a fact.
What do you think about Newton's third law? What's your interpretation of it?
All right, so I've done that in videos. I've stated how I think of it as currency, okay? Energy is currency. And the fact is that you can't give something a currency that doesn't fit in its bank, so to speak. But that's just money. It's just an amount of something. And you can't make more of it, and you can't destroy it. So you just follow where it goes.
And oh yeah, in some other video, this is the title from a few weeks ago.
So now he's quote mining from different videos. So I deliberately, again, isolate the argument in these videos, show the points I want him to address, and so at least this is one of those I'm drawing, so that's better.
That's something like this.
Velocity. All right, and so we did a simple experiment. You put ones and ones on here, and nobody would doubt, in a sense, that this experiment's been done so many times. So this is so ironic because he's going to actually try to defend what has to be a junk experiment, because it's ironic in the sense that the spring produces less momentum. All right, the lighter the objects are I put on it, less and less momentum. So, I mean, it's kind of saying, well, you're destroying an awful lot of kinetic energy then also. In spite of the fact that you get higher velocities, you don't get nearly high enough to overcome the losses from the fact that you've destroyed so much momentum. So the theory is the lighter the objects I put on here, the less energy I get, the less momentum. And the heavier they are, the more momentum. Complete breaking of any notion of conservation of momentum. You get the same velocity this way that you get this way. And if you put a double mass here, you'll get 1/2 the velocity going this way. So there is this sense that momentum is certainly conserved in these environments. Substantial evidence that it is perfectly conserved.
Perfectly conserved. So which one is it?
So again, this quote mining. He doesn't even play the rest of the video where I point out, well, now I'll put the 2 masses on, and he says he gets twice as much momentum out, twice as much. So I put light things on, I get a certain amount of MV. I put heavy things on, I get more MV from the same exact spring compression. Complete violation of any notion of Professor Lewin. So why don't you play Professor Lewin saying it? Nature can deal with kinetic energy one way or another, but nature can't finagle momentum. Why don't you play that clip and explain to Professor Lewin how he's full of shit? Because that experiment that done by Michael's physics or whatever exactly states that that's a piece of shit.
Here's one last clip.
This one, they merge and they continue, and then you'll see.
Right, so this is just 5-ton train into, moving 10 miles an hour into 5-ton train moving 0. It becomes a 10-ton train. The momentum is completely conserved, and yet we lose half the kinetic energy, but we have all the momentum still.
Yes, momentum and kinetic energy are not the same thing.
Not an answer. So what exactly about momentum don't you understand? That you can't invent it out of nothing and you can't destroy it. So it has to be conserved. So how did you move things? Other things are flying in the universe somewhere. They have the momentum. It's a bowling pin. The ball hits it, the pin flies off. The bowling ball can't keep its momentum. It can't have the same momentum. It's just shot a pin into space. The momentum is now in the pin. How the fuck can it still have the same momentum?
So here we have the scenario you described. So 5 mass 10 velocity object hitting 5 mass 0 velocity object so that they stick together. So we end up with 10 mass 5 velocity object. Momentum was conserved, but we lost half of the kinetic energy. So what's happened?
And the heavier we make this other object, the more momentum we'll lose. I mean, the more kinetic energy you'll lose until you get to completely losing it. All of it.
In the comment section of my previous video, there was a suggestion to consider this scenario in reverse. And I
made a video specific to that subject. I read the comment and I made a video responding to the comment.
That was a pretty good idea. So let's start with 10 mass 5 velocity object. Then something happens here so that these objects get separated. So we end up with one 5 mass 0 velocity object and 5 mass 10 velocity object. So again,
exactly what I contend a spring will do, exactly what I contend a lever will do, and exactly what I contend hydraulics will do. All of those things will do that. They will convert a 10 mass going 5 into 2 5 masses or 1 5 mass going 10. Fact. That's what they'll do.
Momentum was conserved, but now we have twice the kinetic energy here. So what happened here? How did these two objects get separated?
So he just wants me to redo the video I did 2 days ago where I answered this question. So I guess it took him so long to post this or some other kind of bullshit that I've already answered this question. I mean, yes, it's just a physical fact of the universe that things stick to each other easier than they fly apart from each other. You have to add energy to get things to fly apart. You don't have to add energy to get things to stick because it's a push universe, frankly.
Because obviously they don't get separated spontaneously. Something needs to be done. You have to do something. You have to do some work to get them separated. Basically,
Well, as I pointed out, there are ways of doing the experiment where you don't have to do some work because you store the work of combining them. So you take advantage of gravity or friction and you put a spring between the two objects and then you store the energy and use it later to release the two objects. And that, yes, that is doable.
these two objects, they need to push against each other to achieve this. For example, you can put a compressed spring in between these objects here, let it...
Yes, it takes pressure for anything in the universe to explode. So there's no argument here. Yes, the universe runs on gravity. Gravity creates this circumstance that it's really easy to push things together. It's really hard to separate things. It's a fact of gravity. Okay, it's not a fact of some intrinsic fact that somehow these things, this energy is, you have to add energy for any other reason. This doesn't prove kinetic energy. It doesn't indicate your theory at all. It's just a fact of nature that, guess what, the universe clumps.
decompress. It pushes against
For free.
both of these objects. It stops this object and gives this object twice the velocity. So this is the way you separate these two objects. You have to put some energy into the system. So what it means in terms of this initial scenario is that you will lose some energy.
So again, I did a whole answer to this, and you still post this video. Fucking such bullshit.
When you force these objects to stick together. The energy is lost as heat energy and deformation of these objects.
Yeah, so big lie, frankly. You never proved it. You never proved it there's any heat. You didn't collect it. You didn't collect any deformation. You haven't shown anything that actually physically happens to that object to demonstrate half the energy went somewhere. Nothing. There's no evidence of any of it. You have no experimental evidence that it got substantially hot or that any of that crap ever fucking happened. So it's just made up. You're just making up a fable and telling me this fable that there was a whole bunch of energy that did work in the universe and it didn't use any momentum. You didn't have to use any of the momentum going in to do all of this heating and deforming and reshaping and whatever crap it did. All of that crap was somehow, you didn't have to use any momentum, which in my opinion is so anti-logical and scientific. It's vomit worthy. It's so stupid an idea that you can make something happen without using something's momentum. Every bit of physics says you have to have something with momentum for something to happen.
So that's the explanation.
Bullshit.
And this brings us to a quite interesting thought experiment. I know you love my thought experiment, so here's another one.
Yeah, go fuck yourself.
Just one, I promise. So here we have an object with some mass, some velocity. It hits some sticky wall, so it doesn't bounce off, but it sticks to the wall.
Right, now just make the other side of the wall reflective. And your physics completely breaks down. Because then you're going to say this side only has one momentum, and the other side got two momentums. And so this thing should just keep going faster and faster and faster all by itself. So all I have to do is create a piece of foil on one side and something black and sticky on the other side and throw it into space, and it'll automatically get to the speed of light and go shooting through the universe. By your theory.
Now we know that when the object was moving, it had some movement related energy. Let's not call it momentum or kinetic energy because those already have definitions. But
fuck you. There's already too many definitions. The two is already too many. Energy is a concept in the universe, period, okay? And it should be, that's it, okay? There's not different energy. There's just energy. So quantity of motion, I don't mind calling it that. But the fact is that's all there is. That's all that's happening in the universe is things with this quantity of motion, this energy, this capacity to move are affecting other things and causing them to move. And that's an exchange of energy.
Let's call it something like movement energy. And how should we define this movement energy?
So isn't this so evasive? His own formula says mv, 1/2 mv squared. We know what it's made out of, mass and velocity. There's not movement energy, there's mass and velocity. That's what's in the universe, masses and velocities. There's momentum in the universe. Photons have momentum, okay? They're not massless. You just say they're massless. You have no proof they're massless. You don't even have a reason to believe they're massless. You just say it.
Energy that an object has because it's moving. Well, if we take a look at the momentum, definitions of momentum and kinetic energy, what they have in common is the mass. So it's probably mass times something, but what?
We already know what it is. So what is this? What is this crap he's doing here?
Something about velocity, but we can't really agree on about the function, what we are going to multiply. So
well, I don't understand. It's mass and velocity. The only difference is you have a silly half and a silly squared. That's the difference.
Let's just say it's some unknown function of velocity. It could be just
fuck this. Some unknown function of something that's already well defined. Velocity is a movement through distance in an amount of time. That's velocity. That's it. It's not complicated. It doesn't have multiple functions. It's a vector.
Velocity itself, so then it would be the same as momentum, or it could be velocity squared, or 1/2 velocity squared, so then it would be the same as kinetic energy. But we don't need to know that. It's just some unknown function of velocity.
Oh, fuck this.
The object had as energy when it was moving. But now it got stuck to the wall, so somehow the energy was lost. So the energy was conserved, but it went somewhere. So it was lost as deformation of the object or as heat energy. And for simplicity, let's just say heat. So some energy, well, all the movement energy was now lost as heat. So the amount of heat.
And so heat, in my argument is heat is momentum. Clearly, you only measure it through measuring movement of matter. Heat is momentum.
Energy is the mass times the function of velocity. Okay, so far so good. But now let's consider a different scenario. So now we have two objects with the same mass and same velocity as the previous object. And now they are approaching each other, so they collide and again stick together. So how much movement energy we lost now? Isn't it twice as much as in the previous example? Because now we had two objects both having the same mass and velocity, and all that was lost. So I think it's 2 times the mass times the function of.
Again, this is so trivial. I mean, yeah, we all know what happens. Either you have a soft object, okay, and it deforms, but if you do this with a hard object in Newton's cradle, the two things are going to fly off with the same momentum. So this idea that you can force them to stick to each other, well, go ahead and try that. Because whatever you're using to stick them together is going to obviously be making a mess. So go ahead and do that experiment.
Velocity. Okay, then let's consider one more scenario, almost the same, but just a moment.
I mean, there's no theory to this, right? If I take two wrecking balls and I smash them into each other and they're lead, they're going to deform all over the place, right? I mean, there's no way to do this experiment without either visually seeing the momentum being conserved in the sense that the things have to bounce, or the things have to merge. They have to break into each other and break all of those atoms to do it.
Yeah, but now we give one object twice the velocity and the other object we give 0 velocity. So this moving object hits the stationary object. Again, they stick together. And now, before going any further,
so this is the same experiment. 5-ton train, 0 velocity train, 5 tons. They stick to each other and they move off as a 10-ton train going half the velocity. Yes. Perfectly conserving the momentum.
Isn't this impact the same as this one, at least in terms of heat energy lost? Because the velocity difference is the same. The difference is 2 velocities.
It isn't. So again, so if he made this immovable, I don't even understand. So he's just increased the velocity and said this crashes into something that doesn't move, and somehow we're not going to know exactly what's going to happen, like it's going to break twice as much. So again, we're just back to car crash evidence that already demonstrates your kinetic energy theory's crap. Okay, because if I crash cars, they're just going to show 2-to-1 relationships. They're not going to show 4-to-1 or 9-to-3.
Here's the velocities is in opposite directions, so that's why the difference is 2 velocities. So I think the amount of heat energy, the amount of movement energy we are losing as heat is the same. So it's twice the mass times the function of velocity. Now, we also know that this object here, these two objects stuck together, they keep moving because of the asymmetric momentums. So they...
What are you talking about? Just 1 minute they're moving, 1 minute it's not moving. What are you talking about? Shit.
They keep moving with
half the velocity, right, perfectly conserving the momentum and destroying half the kinetic energy. Wasting it some magical way.
2 mass and 1 velocity. The momentum is, of course, conserved. And now, based on the conservation of energy, we can write down an equation. This is a simple equation. So, what we started with...
Okay, a complete lie, because he's basically saying that somehow it's the same energy when the object doesn't move as when it does move. So when it does yield, that somehow it's the same impact, the same deformation, the same heat. No, it isn't. That's the whole point. It's yielding, it's taking the energy, it's accepting it, it's accepting the momentum. No reason to think it gets hot when the thing moves.
It was the 1 mass object moving with twice the velocity. So its movement energy is the mass times the function of the velocity, but now twice the velocity. The function of twice the velocity. And where did it go? This is the other side of the equation. Well, some of that energy we lost as heat energy. So that's the twice the mass times function of the velocity. Just 1 velocity now. And this object.
So we know that this doesn't work. Okay, I mean, if I hit the 2 steel balls against each other, I'm likely to conserve the momentum and not have much heat or any of that crap, because they're not going to yield, they're not going to bend, they're not going to distort, and especially in ways that aren't elastic, in the sense that they'll restore. And that'll be the fact. You'll use up the energy in the crushing. So if I make cars out of jello and I make cars out of steel, I'm going to get very different actions to doing this experiment, depending on what material I use. And it's just going to demonstrate that, yes, the momentum would be conserved, and that I'll have a bunch of little bits going all over the place with the jello, and with the steel, I'll have two big objects that still have the momentum.
These two objects stuck together, they get moving, so they some of the movement energy was remained in these two objects, or this one object.
Well, obviously, all of it remained. You have twice as much bread, and now you have thinner butter, but you have the same amount of bread and butter.
Two mass object. So it has the movement energy of 2 mass times the function of velocity. So this is our equation based on the conservation of energy. Now we can divide both sides with the mass. So what we end up with is the function of twice the velocity equals to 4 times.
So in all of this, in these 2 years, this is the best they can do. This plead for a show me experiment. Show me. This is showing. This isn't showing anything. This isn't proving anything. This isn't demonstrating anything. He's just going to court and talking about the theory of the gun. He's not going to produce it on the table. He's not going to show the gun. He's not going to say in any way demonstrate that the gun actually exists. He's just going to make up a fake gun and say it was in that guy's hand. It's just a story. A fake, phony fable.
The function of just one velocity. And what this means is that if we double the velocity, we get 4 times the movement energy.
So it doesn't make any sense. You obviously don't have 4 times the movement energy. It obviously wasn't conveyed. There is no extra butter anywhere. It's just a big fat pile of crap.
And I think we can call that kinetic energy at this point. Okay,
call
that
it,
was it.
Gremlin.
Bye-bye.
Gremlin, that's what you should call it, just Gremlin. Okay, it's meaningless crap. So just a horrible video. Horrible. Pile of manipulative shit. See what kind of comments it has. Let's see. So this is his own comment. I don't know what this other name is. Wasn't the point of the gun and bullet thought experiment that it is somehow strange that more kinetic energy is going one way? No. The strange part is exactly the same momentum is going both ways, and you're pretending there's somehow the bullet is got 2,000 times or 1,000 times more something. And the argument is where? Prove it. Prove it has more something. Despite Newton's third law. So again, Newton's third law is a law about momentum. Newton didn't believe in kinetic energy. He opposed it directly as a theory. He thought it was rubbish. But now apparently the same thing can happen with momentum as well. Apparently from whose perspective? By your made-up theory. You haven't proven it. You haven't shown me the spring not conserving momentum. No need to divide by m. I don't know why I did that, but that makes no difference. Whatever. But it's such bullshit. So what's this crap? Some new crap head. Oh, look at all this crap. Velocity is the rate of change of position. It's a rate, and it has to be understood as 9.8 to 1 is the ratio, 1 second. If you make it 2 seconds, then it's 19.6, and if you make it a half second, then it's 4.8. The ratio changes if you're going to change the number of seconds. If you are traveling at 10 meters per second, every second your position changes by 10 meters. Yeah, no it doesn't. That's the catch. So you got that wrong, because you're accelerating at a rate, and the rate is really how long does it take you to get to that speed. You don't get that speed all the time. Velocity is how many meters you travel per second. I don't know. Velocity is the rate of change of position. If you are traveling at 10 meters per second, every second your position changes by 10 meters. Well, that's correct. But you won't be traveling that speed until you're accelerated to that speed. So you have to understand the difference between acceleration, right? Acceleration rate of change in velocity. Yeah. So again, so what does it have to do with per second per second? I mean, I could have said my velocity is per second per second. And if I did, then I'd have squares all over the place. If you are accelerating, so this is just going to be more of that same crap. Let's see. He is willing to say your acceleration is 9.8 meters per second, so every second you gain 9.8, but won't finish the sentence. 9.8 what? Every second you gain 9.8 seconds, not 9.8 meters. I don't, what's... I'm saying it's a unit of increase in your velocity. It's 9.8 and you get 1 unit of 9.8 per 1 second. Where does this seconds squared come in? So whatever. So yes, you only fall 9.8 meters. Yes, right. But your speed, the fact is you have acquired the 9.8 velocity. So it doesn't matter what your acceleration was. It only matters what your velocity is. What's your velocity after 1 second? It's 9.8. And it does that every second. Yes. So it's 9.8 times the number of seconds, which perfectly matches your velocity and doesn't create any of this second squared crap. So here he says it increases 9.8 every 1 second. Yes. That's 9.8 meters per second. And then he goes per second. So again, they did it again. They just keep saying per second for absolutely no rational reason. At what point along the line of reasoning do we lose him? At the squaring the seconds, this per second part right here. Meters per second per s. You have m/s, and then you say per second. That's the part that's no good. What's an extra per second doing there? But why is it needed? And again, you're missing the 1, right? It's 9.8 times 1 meter, okay, divided by 1 second. Okay, at what point along the line? Okay, at some point he will interrupt reading and say you can't square the seconds. Of course, that's what I'm going to say. Or it's per 1 second. Yes, and 1 square is 1. So it doesn't matter if you square it or some other straw man distraction. So it's a straw man to point out the obvious that it is 9.8 meters per 1 second. It's not 9.8 meters per any number of seconds. It's 9.8 meters per 1 second. That is a fact. Oh, fuck. The thought experiment was good. I've seen that before. Energy equals blah, 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 blah. What? This goes back there. So fuck this. This is just too ridiculous. So again, just a complete evasion of the subject. All my arguments, there's really no point making them because they won't go anywhere near them. That's the simple truth. I mean, I can draw the planet, I can draw the distance, I can point out that the faster I go by the planet, the less I get bent, proving that gravity is a time-dependent force, not a distance-dependent force, proving that you don't have the same amount of gravity per foot, proving all of that crap, proving your whole theory is mush. Okay, it's clearly just made on the fact that you can't interpret data correctly. You can't interpret a physical phenomenon and look at it and see for what it is. Gravity is in fact rain or a paint sprayer. It is in fact something you collect, and you collect it based on how long you're freely in it. Okay, that is unattached to anything and allowed to freely collect it. All right. So I guess we'll do comments on the other stupid video, frankly. Michael's physics video. There's a few comments there, so that's worth reading, I suppose. This is so depressing. I mean, this can't come anywhere near the real argument, and they won't concede the obvious fact, which is physics has had 300 years and literally billions of dollars, and it hasn't done any of these experiments. None of them. Hasn't touched the subject. Oh, there's less comments. Something happened, I guess. All right. So let's see, this wizard guy, let's see what he said. And demonstrate a system where the classical ideas of conservation and energy do not hold. I'd love to see it. A lever. Yes, very good. A mass on one side, half mass on the other, twice as far from the fulcrum. Half mass gets 2x the energy by the KE, 1/2 mv squared. Put the 1/4 mass 4x further out and you get 4x the energy, and so on to infinity. By the KE formula, levers are free energy devices. There you go. KE is indefensible. Look, it's indefensible on its face. Again, the theoretical argument is if you conserve momentum, you can't believe in kinetic energy. So if you can conserve momentum in objects of different size, then you're going to prove, okay, so if I can make the energy from a 10-ton train and I can plow it into something and I can, a spring, and then I can capture that momentum and then replace it with a 5-ton train, I'm going to get back the same momentum. And when I do that, I'm going to get back twice as much kinetic energy. And that can't happen. That's the experiment they haven't done, and frankly would prove the case. Alright, so mindless shit for brain. A lever, a mass on one side, half mass. Wrong. When the lever starts moving, both sides will get a portion of the energy, meaning the energy will be shared among both masses. So he doesn't understand an oscillator. Half the mass won't get 2x the energy. So he says it overtly that somehow it will not conserve the momentum. But the 1/4 of the mass far out further will get 4x the energy. Okay, that's the quote. He says wrong again by the same reason. So there's no same reason here. He's saying that somehow, even though it oscillates perfectly at that 4-to-1 relationship, 4 times the velocity for the lighter object, that somehow if I stop the lever from moving and allow the masses to move freely, that they won't be doing exactly that. They'll just continue moving at the speed they were moving. Of course, they will continue to move at the speed they were moving, and they will demonstrate that I have 4 times the energy on one side of the lever than I have on the other side by their reasoning. Okay, there you go. Let's see. There is a video of this experiment being done. Is there a video of this experiment being done? So Mindless asked this. Where is the demonstration being done? Yeah, I could ask you, why hasn't conventional physics done these experiments? Why haven't they repeated the Eddington experiment? Why? Why haven't they done that? 400 times better resolution from space. Why haven't they done it? Really simple. KE is indefensible. Your comment provides no evidence for the claims you make. So your claims have no evidence. So you're just a duplicitous hypocrite, which is kind of obvious. You're claiming I need evidence when you don't have to have any. I mean, it's just duplicity. And you mess up the math. Do you want to correct them or to admit you were wrong? So what a joke. So there's no counter evidence here. There's no counter argument, frankly. There's no reasoning to explain it. He doesn't have to. Levers don't conserve momentum. That's his argument right here. Levers don't conserve the momentum. So why do the professors keep saying you have to conserve the momentum? So Hero, do an experiment. Why doesn't your physics do an experiment? I mean, why should I have to go crash cars into brick walls or do any of that kind of crap, right? Oh, that's right. We have those experiments, and those experiments don't indicate KE is real. Let's see. So, but it's just ironic, right? I mean, you can't get more duplicitous. The whole argument is, where's your evidence? And your counter argument is, where's your evidence? No, you have to explain where yours is first. You're the one who's had 300 years and billions of dollars. Why haven't you done any of these experiments? The KE theory says the existing object will have the same energy. Exactly. So the KE says you're going to conserve the kinetic energy. Well, frankly, you have to pick one. You can't conserve both. You may think it will leave with twice the velocity, but I suggest you check. Well, yeah, I suggest you check your evidence and see that you don't have any. So why don't you produce a piece of evidence? Why don't you show us it taking 4 times the fuel to go twice as fast? I mean, somewhere. Why don't you show me that? You lying, hypocritical, duplicitous piece of fucking goddamn shit. Your comment provides no evidence for your claims. So, exactly. So there's no evidence. That's the argument. And whose fault is it that there's no evidence? Is it the physics, the science of physics that's had 300 years to produce this simple little experiment showing that, look, it takes 4 times the gas to go twice as fast. It takes 4 times the electricity to go twice as... So show me the 4-time thing. Show me. Okay, so then this physicist Michael chimes in. Oh, look at all this. Oh, good. Big pile of crap, no doubt. All right, try it. Why don't you try it? Yeah, please. Why doesn't your physics do the experiment? Why don't you make a lever and then show us that levers don't conserve momentum? Okay, you've already shown, admittedly, you have done a physical experiment where you've shown springs don't conserve momentum. That, frankly, I can compress a spring a fixed amount, and if I put different masses on it, I can make all kinds of different amounts of momentum. I'm arguing that obviously that doesn't happen, and obviously your instruments were shit, and you calibrated things wrong, and you did the experiment wrong because you really can't make free momentum out of the spring. And you can't destroy its momentum either. Get a meter stick or a long uniform plank and put a fulcrum at the center. So he obviously knows how to do all that stuff already, moron. I mean, asshole. That's what you are. All right, this patronizing crap. Okay, the guy's made the point. We're talking about levers now. You can't up your game a little bit and talk about how a lever works and explain to us how it doesn't conserve the momentum? How there isn't going to be the same momentum on one side that there's going to come out of the other side? Well, why don't you explain how levers don't conserve momentum? I mean, they've only been around for thousands of years. Shouldn't this be a fact that everybody's been made aware of? That, hey, don't trust your lever because it's going to destroy a whole bunch of momentum or make a whole bunch of it. Put a mass on the left side and a half mass at twice the distance on the right side. So the guy already illustrated this experiment, right? So he's just as patronizing to other people who comment as he is to me. All right, this patronizing shit. It'll balance. Yeah, we're not talking about the balancing part. We're all conceding that. Okay, that's the whole point, really, is that somehow they now weigh the same. That's what's being demonstrated. Their weight, and their weight is basically mass and velocity, is now equal. That's the whole point being argued. And now any force you put in to interrupt that, frankly, is going to produce twice as much kinetic energy on one side. The momentum will be perfect. Momentum works. Kinetic energy will go all kinds of funky. It won't move if you just let him sit there like you said. It'll be in equilibrium. So he's so stupid, frankly. He doesn't even understand. He's talking about oscillating the lever or using the lever just directly. Push the 10-ton train in and see if the 5-ton train leaves at twice the velocity. If you actually start pushing down on the left side, you'll only get half the output force on the right side. So says him. Force defined by what? You'll get it. The momentum will be conserved, but the force won't be. So more bullshit. Obviously the pressure will be different, but it's actually the same weight on both sides. But moving the left side 1 centimeter will cause the other side to move 2 centimeters. Yes, we all know that. It'll double the velocity, frankly. Yes, doubling the velocity means it has, more momentum. I mean, it has more momentum if it was the same object, but obviously if it's half the mass, it's perfectly conservational of the momentum. I get half the output force over double the distance. which is, again, it's the same momentum. The work done, KE added, will then be equal to the other side. So again, work equals force times distance. So again, this is just absolute nonsense. It's distance in a certain amount of time, so it's twice the velocity, obviously. Energy input equals energy output. So again, just absolute nonsense. So he's claiming levers don't conserve momentum, right? You can't conserve both. It's impossible to conserve both when you have unequal masses. So if you can't even concede that simple point, it's impossible to conserve both if you're taking the energy from two different masses. Impossible. Momentum and kinetic energy get different answers to the same question. You have to choose one of them to conserve. You can't conserve both. And my argument is, yes, it is true. Momentum is always conserved, and nonsense kinetic energy is fake, and therefore it isn't conserved. What you seem to be envisioning is dropping a mass on one side and trying to launch the mass on the other side. Yes, that's the one. Yes, that's the experiment. Thank you. But here you've got an even worse problems. I don't think so. The only problem is that you don't do it in gravity. Do it horizontally. Okay, take gravity out of it. You're trying to use conservation of momentum. He's not using it. He's just recognizing it's a thing. Okay, it's a law. You don't use laws. You just obey them. Okay, but you're ignoring that momentum is only conserved if there are no external forces. There's no external forces. You're making an experiment. You have one thing coming in with energy, okay, and nothing's taking any other. There's no other element adding anything. So that's just bullshit. And there's going to be an external force at the equilibrium point. So at the fulcrum, he's saying. What force is there at the fulcrum? The whole point of the fulcrum is to create an immovable that's going to reflect all the energy back into the objects. So, bullshit there. So he's saying something as elemental as a fulcrum is considered a new source of energy. All right. Which obviously I'm going to argue is just, if you do that in the rest of your experiments, you won't have any closed system experiments. There's always a fulcrum somewhere. You'll need to use conservation of angular momentum around the pivot point to predict the motion. So more garbage. We already have predicted it. It's going to be twice the velocity. It's one side's going to move with twice the velocity of the other side. Now, if you want to say a bunch of momentum is destroyed, go ahead and say that. That every time you use a lever, you destroy a bunch of momentum. Well, go ahead and make that argument. But I'm going to say you're not going to show experiments demonstrating that levers are that inefficient. The mass on the right side will not shoot up at twice the speed. Well, you just verified that it has to, frankly. So whatever speed the other side is moving at, the other side has to move at twice the speed. So you're basically saying the deceleration of the 10 mass will somehow not be deceleration of a 10 mass or something. I mean, I don't even know how you can even say this crap. It has to move at twice the speed of the other side. There's no choice. It's twice as far out in a lever. Lever is a straight line. You can't change that fact. Okay, that the falling mass had just before impact. Okay, so there we go. We got that. He put it in bold. The mass on the right side will not shoot up with twice the speed that the falling mass had just before impact. It doesn't just before impact. Obviously, it's going to start decelerating. So, of course, it's not about its impact speed. We're talking about its deceleration. It's going to decelerate at exactly the one object's going to accelerate at twice the rate at which the other object decelerates. Of course, they're not going to move at the same speed while they're accelerating and decelerating. But it will always be twice the speed on one side that it is on the other side. So the deceleration will perfectly match the acceleration on the other side. And when the two objects leave, they're going to have to leave with what the other side had when it started. So just bullshit. It will be considerably less than this. So he's again saying the lever won't conserve the momentum. The details depend on the properties of the lever, mass, size, whatever, it's elastic or not. So again, more bullshit. Who would make an elastic lever? Elastic, is that the word I want? Yeah. Who would do that? I mean, not inelastic. We want the lever to be rigid. Yeah, that's the point. And the elasticity of the falling masses. So again, what's that? That's not going to have anything to do with it. We're assuming they're going to stick to the lever. Okay, so we're going to make sure that happens. We're going to do whatever we have to do to make that happen. Blah, 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 blah. And again, it's not going to be an issue if you've perfectly selected your mass to your acceleration to deceleration rates. So if you've got the distance exactly twice the distance and you've got everything done right, it'll work just fine. Now, if you put it someplace else, well, then the ratios change, and now you're in trouble because some of it's going to bounce. These effects, whether we're dealing with an elastic or inelastic collision. So again, he's not going to show us any evidence, again, that levers don't conserve momentum, but he's saying it. The momentum will be destroyed somehow in every case. Some portion of the momentum is destroyed, I guess. Now, I know you're going to not going to believe me. Yeah, that's right. I'm not going to say you have any reason to state this crap as being a fact because you don't have any evidence. All right. I'm making a claim, but it's a claim I intend to back up. Oh, good. Let's see that. That'll be very interesting. This is on my list for covering in testing physics videos, probably August or September. Oh, why is it going to take that long? Anyway, but please beat me to it. No, I don't need to. I'm just saying, go ahead. It's great. Go ahead. But don't do it in gravity, please. Do it horizontally. Swing the weights in with a pendulum. Okay, so we don't have any issues about subtracting the actual weight of the objects, which is a part of the problem with gravity. Try the experiment. Make a lever, drop a mass on one side and have it hit a half mass on the other side. Have it hit a half mass. Why would it hit? You don't want to hit anything. You want to push things. So even that's kind of bizarre. And measure the falling object's speed and the launched object's speed and see if the object gets launched with twice the speed the falling object had before it hit the lever. Yeah. Whether it conserved the momentum. To see if this rule that you have to conserve the momentum means anything at all. That even levers don't do it. It would be very, I would be very interested. So, so why don't you get to it? Okay, this is what I mean by actually doing work and testing your ideas. No, what I mean is that you've had 300 years and billions of dollars and you haven't done these simple experiments. Okay, your objection is based on a faulty premise that the lower mass will be launched with a speed twice the speed of the falling object. Yes, and again, you're overtly saying levers don't conserve momentum. So why does Professor Lewin say you can't finagle momentum? But if you do the experiment and demonstrate that my understanding is wrong, I'll change my mind. Well, good. You know, fine. Please do the experiment. Fine. Okay. Will you change your mind if I do the experiment and verify that your premise is wrong? Well, I'd be curious to know that momentum doesn't have to be conserved. So anytime you don't conserve the momentum, I'm going to have a reasoning problem. I'll say that much. I'm going to say, well, how do you destroy it? Momentum is basically made out of the little atoms, right? I mean, you can break everything down into atoms, right? The gun is 1,000 times more atoms than the bullet. And the gun's velocity on each one of those atoms is 1,000 times less. And the bullet's velocity of its one atom is 1,000 times more. That I can understand. So I can understand conserving the little clumps of momentum. But I can't understand how you can't conserve them. So how do I destroy any of the How do I destroy the bread and butter relationship? How do I make the butter go away? That's the part I don't understand. So yes, go ahead and show me an experiment where you don't have to conserve momentum, and I'm going to question the experiment. So you've done an experiment where you made free momentum. I question the character of that experiment in the sense that I don't think it's right. I don't think it was done well enough because, yes, it's, in my opinion, nonsensical. I can't make butter, in physics. The universe has a certain amount of energy in it, quantity of motion, and you just can't make more of it. I've talked to another physicist about this a while ago, and he did not disagree with this statement. Obviously, half the mass object, twice as far out in the lever, has 2x the velocity as it crosses 2x the distance in the same amount of time. The point is the one object, so this is at Piro. I don't see Piro's comments. So, I mean, it's clear that I'm arguing that you can just understand the deceleration rate of the heavy object is going to be a slower deceleration in the sense that it's losing less velocity, starting with less velocity, and it's going to give away that less velocity at a rate, and the other side is going to need to accelerate at twice that velocity, and that's exactly what the lever provides, is a match between the deceleration of the slow thing and the acceleration of the fast thing. It's a perfect match. So it's just making the Newton's cradle. It's basically converting things with uneven masses into things that have the same mass because they have the same weight now. And by making them the same weight, you're able to do the conversion. And so, like a Newton's cradle, the momentum should be perfectly conserved. Let's see. Obviously, a half-mass object twice as far out in the lever has 2x the velocity as it crosses the distance in the same amount of time. And if done on a frictionless enough surface, the objects would properly and easily move across it, or on a ship ideally, on a spaceship ideally. I'd say logically it would leave at 2x the velocity. I don't have good enough equipment to do this well. If some physics labs decides to do it at some point, would be great. Yes, this is a fundamental experiment. I mean, you can't get much simpler than this. Testing levers. I mean, they're thousands of years old. We've been using them as a tool. They're in all kinds of things. Gears or levers, all kinds of things. I didn't even mention gears as being conservative. They're saying gears aren't conservative. So if I use a big gear and I have it attached to a smaller gear on the inside, so I create a 2-to-1 relationship, they're saying I'm automatically going to lose energy, momentum. I can't hit this small gear and make the big gear turn without losing a whole bunch of energy. The big gear won't go twice as fast as the other object was going. I can't conserve the energy using a gear. I can't conserve the momentum. I mean, I'm just saying there's no mechanical way to make that non-conservational. There's no way not to understand that if maybe I'll draw the gear. I mean, it just seems like it's just impossible to reason, any possibility of you demonstrating this false notion that even though they weigh the same, they don't weigh the same. So even though they're showing themselves to weigh exactly the same, they don't weigh exactly the same. I mean, that's the proposition. You're saying I'm supposed to, in some way, change my mind because you're going to do an experiment that's going to prove this not to be a logical necessity. And I'm going to say, well, I can't accept that. Yeah, it doesn't make any sense. So I have I have a gear stuck on a gear, right? And I put these little notches on it. So now I can put weights on it. And so if I put the 2 mass here, the twice as big, and I put the 1 out here, I'm going to get the same relationship, twice the distance, all that kind of crap. And I'm just saying, turning it, it's the same weight. It would feel the same. Moving this, the larger distance, will feel the same as moving the heavy mass, the shorter distance, at the slower velocity. And it'd be exactly the same momentum. So if I put this energy in, I put the 10-ton train going 5 in, I have to get the 5-ton train, okay, going 10. Yes, I have to get the 5 going 10 out. There's just no, it perfectly matches. Whatever this deceleration will be, this will be exactly twice the acceleration. It'll perfectly match. So I've basically fixed Newton's cradle. Newton's cradle can't do 10 mass into 5 mass. And this device allows me to do the conversion. It allows this to decelerate at its slow rate and allows this to accelerate at the fast rate. And it's perfectly conservative. So where you're saying this won't happen, so this will not be converted into this. This will only go 7 miles an hour, or some number. Well, how can I possibly understand where the glitch is? Where's the problem? Why doesn't it do the conservation of momentum? Why isn't the momentum conserved? And where does it go? If it's going somewhere, where the hell did it go? All right, so again, another appeal to their non-existent experiments, but at least he's promising to do the experiment. But again, dropping the objects, a little more dangerous than just hitting things sideways. So try to avoid gravitational pressure wherever you can. All right, anyway, I've talked to another, okay, that's the one we just read. Okay, so that's Pirro, response to Pirro, who didn't say anything, did he? I'm not talking about launching against gravity personally, but I wouldn't mind seeing that experiment done well as well. So yes, me likewise. It's just, I don't think gravity provides any complication because the force against the 5 mass will be easier to lift than the 10 masses, you know. So, I mean, obviously the weight will be compensated for. But anyway, when talking about launching an object, I'm talking about a horizontal lever you can accept that can accept the heavy object well without sliding off, etc. So it can fully absorb its force. And on the other side, twice as far out, half the mass. Right, so you just have a lever on the table. You know, just make a little lever. I mean, this is such a simple experiment, right? It's like I almost should do it. But in principle, I shouldn't have to do it. They've had 300 years to videotape this experiment, and they haven't done it. And that's the point I want them to address, is just how lame and putrid their physics is, that they haven't done any of these experiments. Any of these elemental experiments, they've completely said, fuck you, I'm not doing them, because basically the truth is the experiments won't be to their liking. It won't validate their Jesus theory. This is an evolution experiment. They don't want to see the evolution experiments. All right, so I have a lever. Okay, slides perfectly. I put a little 5 mass right on here, right? And let's just put it this way, just so we make sure that there's not going to be a problem. And we have a little stick on here so it can't, you know, it can't slide down the lever or do anything stupid. And so we're just going to put a mass of velocity going in here, and we're just going to shoot it out here at twice the distance. So let's understand, this is a full lever. We're not going to cheat it. But, you know, just imagine there's more here. And so, yeah, this is going to move a very slow speed, and this is going to move a very fast speed out here. And the idea is that, yes, you have to conserve the momentum. So whatever momentum goes in this side, it's going to come out this side. And you will, by the kinetic energy theory, this simple device will create free energy. Their theory basically requires it. And it doesn't happen, so therefore their theory of kinetic energy is crap. Okay. All right, let's see. And on the other side, twice as far out, half the mass object. So, you know, 4 to 1's even better, frankly. Because then you have even more dramatic differences. Then you're claiming it's 4 times the energy. That can probably leave the lever while at its maximum velocity. This will probably work best on a spaceship. Well, you really don't need to do that, go that far, where there's nothing lost to friction by sliding or rolling objects on some sort of surface. Yes, but you can avoid all that with just pendulums, so you don't need to go that far. And if not, then both the objects and the surface should be as ideal as possible for at least losses to friction. I mean, obviously, just using pendulums works. Lever, swing the pendulum. So heavy mass at one distance, you know, in gravity, one height, okay, twice the mass. And then over here just have the half mass, okay, and it should go 4 times higher, 4 times further up into the gravity, indicating it has twice the velocity. Twice the velocity, 4 times the height in gravity, right? It's just such an obvious, you know, truth that yes, the faster you go, the quicker you get through the gravity. When talking about launching, okay, yeah, we already did that. And both, let's see, and not both the objects and the surface should be as ideal as possible for the least losses to friction. So again, it's not too hard to do. Maybe 2 air tracks. So no, air tracks, bad idea. You know, 1 for each object, and the lever in the middle, for example. But I'm not sure. Pendulums will work great. The only thing you have to get right is that height thing, you know, and you have to have a quick release, you know. So you have to do your quick release thing. You have to make sure you have the velocities correct, and let the lever do the rest. And of course, it is well done experiment, and half the mass object doesn't leave with more kinetic energy than the heavy one went in with. Then yes, obviously the logic I'm thinking is sound at the moment will be proven not to be. Okay. Again, I would just argue that I'm still going to say I have to doubt the experiment because it's just frankly impossible for you to imagine exactly how you make a magical free momentum. And not to speak for DraftScience, but based on what I've heard, that's all he's looking for as well, some well done experiments. Yeah. I mean, it's all I'm looking for, but I shouldn't have to look for it, is the point. The point is they've had 350 years and billions of dollars and millions of scientists, and it's never occurred to them that, well, maybe we should prove some of this shit we're speaking. I mean, we're talking this shit about how it takes 4 times the fuel to go twice as fast. I mean, shouldn't we prove that? You know, and 9 times the fuel to go 3 times as fast? And 16 times the fuel to go 4 times as fast? I mean, we're making these silly arguments. I mean, shouldn't we have to prove them somewhere? All right, Piero. Let's see. Even in your picture of how this works, the one mass object starts slowing down as soon as it touches the lever. So obviously, it's going to start putting its energy into the other object. It has to slow down because it's losing momentum. The other object is gaining momentum and it's losing momentum. And the whole point of the argument is the momentum is perfectly conserved because the rate of acceleration on one side is exactly twice the rate of deceleration on the other side. I mean, fuck. This is granting your picture of things, which is actually also wrong. Whatever, as the lever doesn't slowly push the half mass object up to speed. No, it does it to exactly twice the. It's exactly the necessary speed for it to go twice the velocity. It accelerates it at twice the rate. The energy travels through the lever at high speed. I think it's almost like you have to almost argue that, yes, the speed is pretty close to instantaneously. But anyway, instantaneously through the elastic flexing of the lever. So there's no flexing, but whatever. Let's pretend there is flexing. If it is rigid and not a bar of rubber. Well, obviously, we're not suggesting a bar of rubber, but frankly, I don't know if it matters that much. Okay, so in your picture and in Mendham's, no, it's DraftScience is the name of the channel. DraftScience. Fuckhead. By the time the 1/2 mass object leaves its side, of the lever, the one mass side is no longer moving at the initial speed. Well, of course, it's decelerating. It's exactly a Newton's cradle, right? When one side hits, it decelerates to some extent, and the other side has to accelerate. And it happens really, really fast. So what? The point is the momentum conserved? And yes, it is. Okay, speed of the one mass object. It's been slowed down, so even in your picture, the half mass object would be moving at twice the slower speed, not twice the initial speed. So isn't that just so funny? It's giving away its momentum. Of course, it has to slow down as it gives it away. I mean, I give away $1. Okay, I have $100. I give away $1. Well, I don't have it anymore, so I only have 99. And then I give away another one, and I have 98. I mean, do I have to go all the way through all the dollars to point out that, yes, I'm giving my momentum to the other object? It starts moving with $1, and then it moves with $2, and then it moves with $3, because I'm giving it away. Duh. Anyway, too stupid. P.S. But then again, in reality, that's not how energy is transferred. Me. We have special energy transfer thingies. They're called gremlins. And hobgoblins. Hobgoblins. Yeah, they transfer energy. With their living force decoder ring. Living force decoder ring in action. I mean, this is such a fucking fairy tale they live by. It's just like when a pool ball. See, this is just such bullshit. It's not just like a pool ball. Because pool balls aren't different masses. It's another one. It doesn't slowly push the other ball up to speed. It instantaneously transfers the energy, right? Because, and frankly, it's not instantaneous. It is at the speed of sound in the object. So, but yes, the energy doesn't reflect it all. Because it's completely consistent with what the object can accept. There's the right number of atoms. And you hit something with the same number of atoms as you have, then each atom can just give away its velocity to the other one. It's the same butter put on the same bread. But if you have to start dividing the butter up, that takes time. Let's see. Transfers the energy through the elastic insides of the balls at the speed of sound in the balls, by the way. One instantly stops and the other instantly moves. So obviously it's not instantly, it's the speed of sound. So again, he doesn't even follow his own argument. Instantly isn't the speed of sound. Instantly is faster than the speed of sound. Yeah, it goes on and on here. Alright, well, I'll take a little pause then. Alright, back. I don't disagree that the heavy object starts slowing down. Obviously it does, but so does the lever. So the fastest, the initial impulse will give the twice as far out object most of its velocity, at which point it would start leaving the lever. Right, so the thing that's slowing down is slowing down at exactly the same rate as the other thing is speeding up. And the question is, if there is no force opposing the half as massive objects like in a spaceship ideally or an air track, would it shoot out with more KE? If there is any scenario where it leaves with more KE, KE is done. Exactly. So if it conserves the momentum, the kinetic energy theory is debunked. And just for the sake of it, there's any scenario where an engine doesn't use 4 times more fuel to go twice as fast, or 9 times more fuel to go 3 times as fast, or 16 times more fuel to go 4 times as fast, or really any amount less than it should to match the KE increase. KE is also done. I guess I got those ratios wrong, so it would be, I don't know how to convert the 9 into 3, but the 16 should be 8 to 4? No. Well, anyway, their theory is wacky. Let's see, mindless marbles. Unbelievable levels of dishonesty, he said, and demonstrate a system where the classical ideas of conservation of energy do not hold. So again, this more bullshit. We're arguing for conservation of momentum. That's what Newton defended, conservation of momentum. He didn't defend conservation of energy. All right. You said a lever. I don't know. This is... In another comment, you said, if done on a frictionless enough surface, the objects that would properly and easily move across it, or a spaceship ideally, I'd say logically it would leave at 2x the velocity. Your own comment provides no evidence of your claim. So again, you have no evidence of your claims. You just outright assert things. That's exactly what you do. You assert and you don't have any physical evidence to defend. Okay, and then have the hypocrisy and slander others with what you are doing. So again, you have all the physicists, you have all the money, all the laboratories. Your conventional theory is the one that owns all of the resources, and you have done nothing with those resources to prove your theory. That's the argument. I have no interest in interacting with you. Yeah, that's good. That's all you can say to this despicable, lying, privacy invading troll. Where is your evidence that if done on a frictionless enough surface, blah, 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 blah. I'd say logically it would. So again, it just says where's your evidence that. Okay. Do you have it, or do you want to admit you made your comment with no evidence to back it up? Amazing. So the duplicity of these people, again, these are such simple experiments, and in hundreds of years they've been claiming these truths and they haven't produced any physical evidence. And you can show some evidence that it doesn't work that way. I can show the crushed cars. I mean, I can show things that show no evidence of kinetic energy making itself known. I can show Toady crashing, okay, the two equal momentum objects with unequal kinetic energies hitting each other, and the one that has twice as much kinetic energy doesn't push the collision at all. Twice as much energy, but it doesn't win the contest. Okay. Let's see. Oh, here we go. More. He always types about the same amount. Surprising. Let's see how far this goes. Okay, well, a bit to go. I appreciate this response, but I want the videos that I produce to go beyond any local echo chamber. So again, this is just more bullshit. His videos are just standard crap. There isn't a single thing in them that has anything to do with doing anything new or innovative or challenging in any way. It's all redundant, seen it, been there, done that. And address the questions of people that disagree with or not know all the related physics topics. So again, he's just disparaging somebody else's intelligence because he can't deal with the issue or the question. Okay, I encourage anyone else reading this to also exercise as much patience as they are able to all around. So we should wait 396 years, and then we should wait 444 years, and then we should wait 697 years before you decide to get around to actually proving the crap you spew. You spew this stupid theory, and yet you can't produce a single piece of real physical evidence demonstrating it. Clearly, I'm not going to be able to do this experiment on a spaceship. So, yeah, I'm sorry he introduced the spaceship. Not in my budget. Well, none of the shit you think I should do is in my budget either, fuckface. God damn it. It's just amazing hypocrisy. But the horizontal lever might work better than what I was originally picturing. Excellent. Fantastic. I'm glad you got that. As I mentioned, there are going to be differences depending on how the experiment is set up and whether we're going for an elastic collision. I don't know how else you would do this. You're trying to get it to stick to the lever, so obviously sticking to the lever would be sort of important. The math is a lot easier to explain, and setup is probably easier as well, but we'd be losing some kinetic energy, and even though we could predict how much KE would be lost, I don't want that to be a sticking point. You're going to be making free energy, so it's no problem. You don't have to worry about losses, but you're going to be making free energy, okay, on whether the experiment is valid or an elastic collision, more complicated math to make the specific prediction, and don't want that to be thrown out as some kind of made-up math. Well, of course, the math isn't going to make a goddamn bit of difference. Again, one is accelerating at twice the rate, and it's half the mass. Of course, that's perfectly consistent. It's not really going to be an issue. Your math is going to say that. At what rate is this thing accelerating on the other side? The lighter mass on the other side. At what rate is it accelerating? Well, it's accelerating at twice the rate. There's not going to be a mathematical problem. Maybe using the two low friction tracks with the spring repelling magnets on the incoming cart would get close to an elastic collision as possible. I have to think about this. Pendulum. Just use pendulums. Basically, I want whatever the experiment set up, especially long pendulums, to be as unimpeachable as possible. Yeah, that would be really great. So I would suggest not using your friggin' whatever Wi-Fi, radar detectors of velocity, because frankly, I think they're not working very well, because you have spring experiments where you create, extra momentum. Whatever the result, I'd be very happy to hear your thoughts on what kind of test you'd be most convinced by with these two options. Just please verify you have the velocities correct, and that we're done. Okay. I'd be very frustrated if it went through a lot of work to set up and perform the test just to have the results rejected out of hand. Well, then why don't you solicit somebody else to do the experiment? Somebody who has a laboratory and can do it well, like I have. Why don't you join me in trying to request that one of the channels where people are doing, physical experiments all the time, we get one of them to do it. Like DraftScience flat denial of the experiment where I used the spring to launch different mass carts and showed the spring producing the same total kinetic energy in the carts with each trial. Yes, and producing different amounts of momentum. So the same spring compression created different amounts of momentum, violating conservation of momentum, as I pointed out. So this idea, he says flat denial a thing again. I don't flatly deny any of it. I deny it with a rather complete explanation of why I think it's rubbish. Also note that I'm not a great builder, so there are always going to be limitations to accuracy in any experiment, which brings us back to the subject of the video, random and systematic errors. Yeah, which again I'm arguing you conceded that your photo detectors of velocity aren't very good, when they're facing each other, and but you don't take any responsibility for acknowledging that maybe you're getting false readings. With whatever experimental setup there is, hopefully we'll be able to get a clean enough data to settle this question. It does seem so simple, really. Yeah, as I said, yes, and the question will be settled is whether you have to conserve momentum in a closed system. As I said, it'll probably be August or September. Well, I'm not waiting for that before I can get to this experiment set up. I've got a few other experiments on momentum showing it's only conserved in systems where there's no external forces, like a fulcrum. Yeah, and that momentum is a vector. Yeah, we already know that. So direction matters. Yeah, go ahead, keep doing those experiments. That I'll be getting to in the next weeks. Well, you've already done the free momentum experiment. I don't know what you're going to top it with. I hope you'll consider the points made in those as well. Yeah, whatever. There'll be more violation of conservation of momentum experiments because he thinks you have unmomentum. I can shoot a bullet that way and undo the bullet that went that way. On balance, the lever scenario you've laid out, I'm not disagreeing with that the two-mass object being half the distance to the fulcrum will lose its force twice as fast to the fulcrum. No, it won't. It'll lose its momentum exactly at the same rate. So they're using the word force as if force isn't momentum. Again, I can't think of it any other way. Newton made it clear. Force equals momentum. Force equals velocity in this case. That's why you have to put the less massive object twice as far out on the balance. And yes, they are equal in that scenario. Yes, they weigh the same. Moving the same weight takes the same amount of energy. If I move 9 pounds and then I go and I move 9 pounds, it's 9 pounds of movement. It's going to take 9 pounds of work. The point is, you apply any force on other side of the lever will move up and down before it balances again. Well, that's my point, frankly, yes. While they're moving, the KE stays. While they're moving, the KE says that the smaller object has twice the energy the entire time. Yes, it's oscillating with twice the momentum in its peak velocity. So when it gets to the middle, it's always going twice as fast as the object on the other side. Are you disagreeing with that? Momentum says they are the same. Force says they are the same. KE says nope, even though they're clearly the same. Let's see. So Physics Michael probably won't answer that. I'd be interested to see your answer and reply to. I'd be very happy to hear your thoughts on what kind of tests you'd be the most convinced. So this is just quoting people again. And I'd be very frustrated. Work set up. So he did all of this quoting, and I don't see any real text here anywhere. So again, I didn't flat deny. That's just a lie. I explained why I find it implausible that you proved springs don't conserve momentum. I'd be very frustrated. So here's more quoting. Okay. DraftScience has painted himself into a corner. No, you're in the painted corner. Okay. Anytime there's a transfer of momentum between different masses, your theory requires destruction of energy and creation of energy. You're in an untenable corner. Okay, because half his statements contradict the other half. That's a lie. So let's see. He claims that. Let's see what he'll lie about here. Newton never got a wrong answer by treating momentum as energy. Yeah, it's true. So where did he get a wrong answer? Where did anybody prove Newton was wrong about something he said about how things move in the universe? This is falsified by the simple experiment where a cart with a velocity v runs into a stationary double mass cart, which then takes off at 2/3 v. So he's citing the very experiment that I'm saying is the most corrupt experiment done on YouTube, in the sense that every single video produces slightly different results, and in some cases, quite obviously, they don't produce things like an actual measurement of masses of the carts, and there's all kinds of reasons to suspect they don't have a straight up setup, because they don't test it first and show it's working properly. And the initial cart recoils back with minus 1/3. That is one of the reasons KE is needed, because treating momentum as energy runs into this contradiction. So there's no contradiction unless you believe the credibility of those experiments. Now I can show one done by a high school teacher where she wasn't forcing it to come out right. Okay. And the experiment came out perfect. And then I can show Professor Lewin, the MIT professor's carts, and show how it's implausible that the two carts have the masses he states, and there's big blobs of clay on the carts, creating obvious questions regarding whether the masses were as he stated. Draft's escape from this dilemma is to claim that the experiment is fudged. Yes, that's the claim I'm making. That Professor Lewin, along with millions of high school and college students, so there's millions? I don't know about that, around the world who do this physics every year, have been part of a decades-long global conspiracy which our hero has virtually unmasked from his basement. So I'm not claiming any conspiracy. I'm just claiming that they have huge confirmation bias, and that it's easy to fudge, and they fudge it. And especially with air tracks, because air tracks aren't as perfect as everybody says they are. Especially the cheaper versions, that they are defeating the friction with a new energy source, and they have very little guarantee that that energy source stays even no matter how they bang carts. So why don't they bang the carts into the carts? Well, guess what? Because the carts are less likely to lift up. When you bang the metal into the metal, it's less likely to lift up. But if you bang into a spring first, then it's more likely to lift up. And it's that lifting up that's creating the extra energy. Simple, plausible explanation. Farley won't dispute it with anything. Okay. But anyway, so he's relying on that one experiment. And I'm going to demonstrate through all these other experiments once they're done that springs do conserve momentum, that levers do conserve momentum, that gears do conserve momentum, that hydraulic systems do conserve momentum. And in all those cases, they will prove kinetic energy theory is nonsense. All right. So, enough of a video. 2 hours. Shit. Well, whatever. It's got to be done, I guess. At least I'm fair to their crap because I actually read it and I don't quote mine it like these characters do. Alright, so till the next time and such and so forth and whatnot. This has been a DraftScience on YouTube. It's the name of the channel, DraftScience. And then there are 2 websites, draftphysics.com and debatephysics.com, where there's a lot of videos on the websites. But anyway, the debate physics one has this subject isolated with some of the better videos on the subject. And so I think I will post yesterday's video, but I won't post today's. Because today's is full of a bunch of nonsense and crap. Provoked by people who are not really interested in getting to the truth and just interested in playing rhetorical games.